A kicker in a football game attempts a field goal of 45 yards from the goalpost. The ball is on the ground and is kicked with an initial velocity of 71 feet per second at an angle of 58 degrees. The height of the crossbar on the goalpost is 10 feet as shown in the diagram. For the field goal to be good, the ball must pass over the crossbar and between the uprights. Assuming the kick is straight and passes between the uprights, which conclusion is true? So every 1 yard equals 3 feet. So 45 yards from the problem would be 135 feet. Using the other information in the problem, you can plug it into the projectile motion equations. So vertical position and then horizontal distance. And you have y equals negative half gt squared. Initial velocity sine theta t plus initial height. And then x, you have initial velocity cosine theta and then t. With those equations, you go ahead and plug in the values from the problem and graph it into a parametric. So you're going to have x equals 71 cosine 58 degrees t, and then y equals negative half, and then for g, you're going to use 32 since there's feet in the problem. So half 32 t squared plus 71 sine 58 degrees t plus 0. The initial height is 0 since the ball is being kicked from the ground. Once you have the graph zoom fitted, go ahead and graph trace it, but first you put in 0.001 into trace step just to be more accurate, and then you move it all the way to 135 to the first value. Another way you can solve it is to solve for t and plug in 135 into the x equation, like so. And then that'll give you the t, and then you plug it into the y equation, so half 32, and then you take the t value and just like copy and paste it straight into the equation just to avoid like any rounding errors. And then you plug in the other values, 71 sine 58 degrees, and then t again, and then plus 0, but since it's just 0, it's optional, you don't have to put it, but you can if you want to, and then that'll give you 10.05, which means it's like it'll barely hit the crossbar, and your answer will be D.